and we're going to talk about dilations. All right, so let's describe this transformation. So we're going to say a dilation and before we write our description, what are we going to guess that a dilation is telling us about? How else do we use the word dilation? Your eye's dilated. What happens to your eye when it's dilated? It gets bigger or smaller. So we're talking. So a dilation, very very similar to what we talked about with our eyes, has to do with things getting bigger or smaller. So a dilation, and we always have a center of dilation. So they're kind of like rotations. We always have a center. So our center of dilation is going to be a point C. And a scale factor we call n. And we're going to say that n is positive. Is a transformation where certain things happen. Well, let's keep up with this idea of our eye dilating. What would be the center of dilation of our eye? The very center, right in the middle, the pupil, right in the middle of your eye. And the scale factor, what do you guess the scale factor is telling us about this dilation? How big or small, how much bigger or smaller we're getting. So dilations are just like we think about in everyday terms, scale factor, center. So all of those things are the same. So a dilation, here's what happens with a dilation. The center what are you going to guess happens to the center of dilation after we do the dilation? So we have a point that's the center of dilation. How is it going to change? How did the center of rotation change? Didn't change at all, right? Or a point that was on the mirror line. Didn't change at all. The center is its own image. So the center of dilation doesn't change. And we say C equals C prime. For any other points, any other point P, the image P prime is on the ray from C to P. And the length of C to P prime, so the center to our image point, is the scale factor times the length of the ray from C to P. So what we're doing is we're multiplying lengths by the scale factor. So lengths are multiplied by the scale factor. So dilations do not preserve length. So that's why they're not a rigid transformation. They don't preserve length. But they do preserve angle measure. And I'm going to just re-emphasize not length. So our dilations, lengths are multiplied by the scale factor in dilations. So length is not preserved, but dilations do preserve angle measure. So when else have we talked about some figures where the angles are all the same, but we multiply the lengths by some number? Remember when we talked about figures? What's that? Proportions. When we talked about proportions, when we talked about similar figures, we said with similar figures the angles are all congruent, but we multiply the lengths, the side lengths are proportional. So we ended up multiplying to get side lengths. Dilations give us similar figures rather than congruent figures. So our dilations are how we get similar figures. The rigid transformations give us congruent figures. Dilations are how we get similar figures. Whatever shape we're talking about is 3 times bigger than the other shape, but the angles are all the same. So that's what a dilation is. So let's draw a picture of what this is saying, that the lengths and the rays and all that kind of thing. Let's draw a picture of a dilation. So here's our center. And we said that doesn't change. And I'm going to dilate a triangle. I'll draw a triangle here. And we'll call this triangle X, Y, and Z. Well, we said the image of each of these points is on the ray from the center through each point. So I'm going to draw those rays. I'll do those in dotted lines. So I'm going to draw a ray there. I'm going to draw a ray there. And I'm going to draw a ray here. And our images are on these rays, so let me draw the image points. So I'm going to call this X prime, Z prime, and I'll put our point Y prime there, and here's my new triangle. So our image point is on the ray from C through X. That's where I find X prime. And the distance, that distance, C to X prime, equals N, the scale factor, times the distance from C to X. So if I measured this distance from C to X to get from C to X prime, I would multiply by the scale factor. And I could do that for any of these. The distance from C to Z prime is the scale factor times the distance from C to Z. Same for Y and Y prime. My lengths get multiplied by the scale factor. So X prime, Y prime, the length of this side of the triangle, is N times the length of the side of the smaller triangle. Same with each side of the triangle. Y prime, Z prime is the scale factor times the length of this side of the triangle. And same with this side. X prime z prime is n times xz. So this triangle, whatever our scale factor is, this triangle is the scale factor times bigger. So to find the scale factor, I take the length of the bigger figure, x prime, y prime, and divide, I'm dividing both sides here by yz, divide by the length of the smaller figure. That's also equal, I can do that same thing with this one, y prime z prime over yz, and that's also x prime z prime over xz. I always have my image length in the numerator. All right, we call an dilation and it is an enlargement. If n is bigger than 1. So we're making our dilation bigger. We're making our image bigger. So we're making it 1.5 times bigger. We're making it 5 times bigger. We call it a reduction. If n is a fraction. So if we're talking about 1/2, 1/3, 0.7, 0.02, some kind of fraction, then we get a reduction. If I drew a dilation that was a reduction, instead of being here, where would you guess my image would be compared to the pre-image? If it were getting smaller, where would my image end up being drawn? It would be closer to the center. So if I did a reduction, my triangle would be smaller and it would be over here. So we get an enlargement if our scale factor is bigger than 1, a reduction if n is some kind of fraction, less than 1. So dilations are how we get similar figures. Our similar figures can be bigger or smaller. The angles are all the same. The lengths get multiplied by the scale factor. All right, questions so far about how dilations work? Kind of the bottom line with dilations is we're multiplying. We're multiplying by the scale factor. If the scale factor is a fraction, multiplying by 1/2 is the same as dividing by 2. So if we're making it smaller, we're dividing. Multiply or divide. That's really all we have to do for dilation. All right, in our book, all the dilations, the center of dilation is always 0, 0. Unless they say otherwise, our center of dilation is 0, 0. When that's the case, we write a dilation by a scale factor of n of xy equals x prime y prime. So we're always dilating with our center of dilation at 0, 0. So all we have to do is write D for dilation, n is our scale factor. When this is the case, we can multiply our coordinates by the scale factor to get the image point. So when our center is 0, 0, all we have to do to get our image point is multiply by the scale factor. So an example, if we wanted to find the dilation scale factor 2 of the 0.35, it's telling us to multiply everything by 2. So I get the 0.610. If we said, if we call this A, B, this would be A prime, B prime. So we don't have to put the primes on the numbers, only if we name the point. So multiply. That's all we had to do for a dilation. Multiply. If our dilation were a fraction, 1/2, we'd end up multiplying by 1/2, which is the same as dividing by 2. So we're multiplying or dividing with dilations. All right. What I want to do next is do a few examples using dilations, talking about dilations using scale factors, and using just working with this idea of dilation. Let me get a grid page here. We'll do one that has coordinates, has a graph, and then we'll do a couple of other kinds of examples. So for this one, I'm going to draw a graph, and we want to know, is this an enlargement or a reduction? And we want to know the scale factor. So let me draw my coordinates. I'm going to graph a couple of triangles here. All right, so my first one. We're going to say that this point B is at 0, 8. And I'm going to put A at -8, 0. Okay. And then C is at 4, -8. So there's my first triangle. And then I'm going to draw another triangle in here. A prime is going to be at -2, 0. B prime is going to be at 0, 2. And C prime is going to be at 1, -2. So there's my second triangle. All right, first off, the first question should be really easy. Is this an enlargement or a reduction? This is a reduction. The image is smaller, so it has to be a reduction. All right, now we want to figure out the scale factor. So what do we have to do? So let's look at our coordinates to figure out what we do to our scale factor. This is a dilation about the origin. So to get our image point, we multiply by the scale factor. What do we have to do to 8 to get 2? And remember, we're talking with dilations. We're talking about multiplication or division. Divide by 4. Does that work here? From -8 to -2. Divide by 4. From 4 to 1. Divide by 4. From -8 to -2. Divide by 4. So we're dividing by 4. So our scale factor is, how are we going to write that as a fraction? Dividing by 4. How do we write dividing by 4 as a fraction? What over 4? Something over 4. 1/4. N equals 1/4. Dividing by 4 is the same as multiplying by 1/4. So our triangle is 1/4 as big because we divided everything by 4 to get the other sides. So our scale factor here is 1/4. We get a reduction. So we would call this a reduction by 1/4. Or we could say by a factor of 4. Or a reduction with a scale factor of 1/4. Factor just means we divide it by 4. Reduction by 1/4. Reduction, scale factor 1/4. Any one of those can work. So remember, with dilations, we're always talking about multiplication or division. All right, let's get another page. We'll do a couple of other examples. Let's say for this one, we have a triangle, and our vertices are 1, -2, 2, 3, and -3, -2. And we want the coordinates of this transformation. Well, let's figure out what this transformation is asking us to do. What is D3 of triangle XYZ telling us to do? Our D tells us we're doing a dilation. The 3 tells us scale factor is 3. And scale factor 3 tells us to do what? What are we doing with the 3? Multiplying. We're multiplying. This is telling us multiply everything by 3. So this is an easy problem. Multiply by 3. So x prime, multiplying everything here by 3, I get 3, -6. Y prime, multiply everything by 3, 6, 9. Z prime, multiply by 3, -9, -6, and there we go, we're done. Told us to multiply by 3. And we could, so multiplying by 3, is this going to be an enlargement or a reduction? An enlargement. And we can say it's an enlargement by 3, or an enlargement by a scale factor of 3. So this would be an enlargement. All right, let's do another example that has to do with scale factor, but in a little different way. Let's say we have a 4x5 photo. We want to enlarge by a scale factor (1.25), and we want to know how large is, or the dimensions of the new photo. All right, so what is this problem asking us to do? We're enlarging by a scale factor of 1.25. So what are we doing with that 1.25? Multiply. It's telling us to multiply. multiply by 1.25. So 4 times 1.25 equals 5, if I calculate that out, and 5 times 1.25 is 7.5. So our new photo is 5 by 7.5. What if the problem asked us to reduce? We wanted to reduce by a third, 1/3. What would we do then if this problem were asked to us that way? Divide by 3. Divide by 3. Or we can multiply by 0.333. Same, dividing by 3 is the same as multiplying by 1/3. Same idea. Questions on that example? Yes. Is it 6.25? Did I multiply wrong? I have multiplied by 1.5. Thank you. So this should be 6.5. I made an arithmetic error. Did I do this one right? Yeah, I did that one right. I did this one wrong. 6.25. Thank you. Oh, you know what? I wrote it as 7.5 in one place and 6.25 in another place in my notes. Don't know why I did that. All right. So other questions other than why I made an arithmetic error. Okay. Let me ask you one more question. This about dilation. What if we were given a problem where we have two segments? And I'm going to call this one is AB, my endpoints, and this is A prime, B prime. And this question is saying, find the center of dilation. How could we find the center of dilation for these two segments? This is all the information we're given. Any ideas? Well, let's look back here really quickly at what we said at the very beginning about dilations. And that picture should give us a clue. It says, for any other point, P prime is on the ray from C to P. And let's look at this picture. When I drew my dilation, my ray goes from the center through each vertex of the triangle. So thinking about that, what would we do here to find our center of dilation? Draw rays through the endpoints of the segments. So let me draw those rays. Make them in red. So I'm going to make a ray that connects those two. And I want them dotted. There we go. So there's one ray. Here's another ray that connects those two. Where's my center of dilation? Where they cross. There's C. So we can always find the center of dilation by connecting with a ray the two points, the pre-image and the image, making a ray, making another ray from another image point and a pre-image point, and where they meet is going to be our center of dilation. Nice and easy to find centers of dilation. All right, questions about dilations? So dilations give us similar figures. Rigid transformations, rotation, reflection, and translation give us congruent figures.